Alright all, this is Algebra Section 3, Powers and Roots. Most people who've seen my videos before will know the general layout of the video, but just in case you're new here, I tend to do an overview of the section, I then go through the worksheet, and then I answer the questions given on the worksheet. The description box below gives a link to my Instagram account where you can find images of the worksheets and the answers. I'll link the particular ones associated with this video down below. So, powers and roots. Sounds like a bad attempt at me trying to be catchy, I swear that's not the case. Powers and roots are just two other types of arithmetic operations. Powers are the little floating numbers, like a little 2 here. The roots are the numbers that have a little roof on them, like a little... I tend to find that powers and roots are better explained pen on paper, so I'm just gonna cut myself and let's just go. Right, this is the powers and roots worksheet. It is split into two sections, so we've got the power rules at the top, and then we've got the root rules and the questions at the bottom. Like I said in the introduction, powers are floating terms. If we come over to this example, this expression here is spoken as 2 to the power 3. The 3 is the power term, and it is telling us that we need to multiply 2 by itself 3 times. The answer to this is then 2 times 2 times 2, which is 8. There are about 8 rules to do with powers that you should probably learn. These are mainly simplification rules, but other rules will help you compute certain power expressions. I'm going to run through all of these with an example for each one. First example, a to the n times by a to the m is just equal to an plus m. So when you're timesing, you can add the powers. So here in this example, 2 to the 2 times by 2 to the 3, we can write this as 2 to the 2 plus 3, which is 2 to the 5, which is 32. Next example, we've done the times, time for the divide. A to the n divided by a to the m is equal to a to the n minus m. You see, when we times, we add the powers. When we divide, we take the powers away. 3 to the 4 divided by 3 squared. Well, that is just 3 to the 4 minus 2, which is 3 squared, which is 9. Third example, we've got some brackets here. So a to the power n within brackets, all of that to the power m. At this stage, your powers times by themselves. So a to the n to the m is the same as a to the power nm. In this example, we have 2 squared, all to the power of 3. We can write this as 2 to the power of 2 times by 3, which is 2 to the 6, which I needed a calculator for. 64. Fourth rule, a to the minus n is equal to 1 over a to the n. Really simple rule. If you've got a minus, knock it down. It goes into a fraction. But in this example, 3 to the minus 3, well, that's just 1 over 3 to 3. And that is 1 over 27. Now, people tend to mix up the fourth rule and the fifth rule. I like to think of it as, this has already got a fraction. It can't be greedy and have another fraction, so it becomes a root. This, on the other hand, a to the minus n, there's no fraction here, so we probably need one. Therefore, I remember it as this is the one that turns into fractions. Each of them have one fraction in. That's just a silly way that I remember it. Anyway, rule 5, a to the 1 over n is equal to the nth root of a. 9 to the half, that is the square root of 9. When it's a square root, we sometimes omit the 2. We don't really write it there, but I'll put it for now. So what times is by itself 2 times to give 9? Well, it's 3. 3 times 3 is 9. Sixth rule, a to the n over m is equal to a to the 1 over m times by n. This, you could say, well, that's the same as rule 3. Why even write it? I put this because often if you were calculating this, i.e. the a was actually a number, it's best practice to probably do the 1 over m section first, i.e. do the denominator first before the numerator. So here we have 8 to the power 2 over 3. Let's split that up. Let's do 8 to the third first and leave 2 guy over there. So 8 to the third, well, that is asking what is the third root of 8. So what times is by itself 3 times to give 8? Well, remember from this example up here, we know that 2 times 2 times 2 is 8. So we can write that 2, and then we've still got this power 2, and that is 4. Final 2 rules, just something really easy to learn. Anything to the power of 0 will always be 1. So a to the 0 is 1. So for instance, 207 to the power of 0, that's 1. I went a bit outrageous here and drew an apple. But anyway, it still illustrates the point. Apple to the 0 is 1. A, very similar to rule 7, it's a always kind of rule. So 1 to the power of anything will always be 1. So 1 to the 57, that's just 1. Our good friend apple, 1 to the apple, it's always going to be 1. Roots are sometimes called surds. I really don't know why, I think it's such an awful name, but I've just put it in here to let you know that you might see this word and think, what the hell? But it's just roots. Right, roots. So roots, I think of them as the opposite of powers. If you have a question to do with roots, it's really useful to switch the question around and ask it in a power view. So for instance, this symbol here, this is asking, what is the third root of 8? Now I go, well, I don't really want to ask it like that. I want to ask, right, what times is by itself 3 times to give 8? Now I can work that out. I usually do examples, so I'll go through, I'll times 3 lots of 2s and find the answer. I'll times 3 lots of 3s and find the answer. 3 lots of 4s, so on, so on. And that way you can always get to the answer. So as it happens, 2 times by itself 3 times gives 8. There are 3 sets of rules to do with roots, a bit like above with powers. I actually find the roots ones easier to remember, and there's less of them for now. So, first rule, the square root of a times by the square root of b is equal to the square root of a times by b. The square root of 3 times by the square root of 5, well, that is just square root of 3 times by 5, which is square root of 15. Second rule, square root of a times by the square root of a, well, that's just equal to the square root of a squared. It's using this rule up here, which is just a. So here, the square root of 2 times by the square root of 2, well, that's the square root of 2 times 2, which equals the square root of 4. And we know that 2 times 2 is 4, so we get 2. So you see, this 2 here is the same as these 2 2's here. So when you see the square root of something times by the square root of the same thing, well, it's just going to be that thing. Third rule, square root of a divided by square root of b. Well, that is just the square root of a divided by b. So here, the square root of 15 divided by the square root of 5. Because of this rule, we can write as the square root of 15 divided by 5, which is just the square root of 3. And that looks so much nicer than that. Right, this is the point where you probably want to test your knowledge, and to do this, I'd probably pause the video, try out these questions here, either work them out or simplify them, then come back to this video and you can check your answers and also check your workings.